Chem solution. Welcome all of you. I hope you are preparing for the board exams and the preparation is going well. So today we will discuss the important MCQs of D and F block elements, which are very important, and these are previous year questions, so please be ready with it. So let's start. Number one question: which of the following metal is used as a catalyst in Haber's process? Haber's process is for the manufacture of ammonia. Okay, so the catalyst used is iron. Iron containing molybdenum is the catalyst. Okay, next, when manganese dioxide is fused with KOH in air, it gives. When manganese dioxide is fused with KOH in air, it gives potassium magnet. Okay, let's see the reaction. Plus MnO2 plus KOH plus O2, it will give K2 MnO4 plus 2H2O. This is the reaction, and we will get potassium magnet. When blackish colored compound MnO2 is fused with KOH in presence of air, it produces a dark green colored compound, potassium magnet. Okay, so the answer is potassium magnet. Which transition metal can show highest oxidation state? Highest oxidation state is shown by manganese for +7 for sure, but in this option, scandium, titanium, osmium and zinc, osmium is the correct answer. It will show the highest oxidation state. Okay, next question: when KMnO4 acts as an oxidizing agent in alkaline medium, the oxidation number of Mn decreases by, it is decreases by 3. You know that KMnO4 is oxidizing agent used in alkaline medium, and its oxidation number is decreases by 3. Next, which of the following oxide is amphoteric in nature? NiO, ZnO, CO and FeO. So first of all, amphoteric means which react with acid and as well as base. So ZnO is the correct answer for it. Okay, it acts as a acid and base, both of them. Next question: least paramagnetic property is shown by. Paramagnetic property means the presence of unpaired electrons. Unpaired electrons. Okay, unpaired electrons is paramagnetic nature. So we will see the configuration of all of this. Let's see the configuration. For Fe, the configuration is Ar, argon, 3d6, 4s2. Okay, 2 unpaired electrons are there. For Mn, Ar, 3d6, 4s2. Nickel have also the same. Oh sorry, here it is the 5. And for nickel, argon, 3d8, 4s2. Okay, and for the copper, the electron configuration is argon, 3d10 and 4s1. So the unpaired electron is 1. So least unpaired electrons and least paramagnetic property it will show. So copper is the correct answer. Next question: process the properties of both alkali metals and halogen. Helium, hydrogen, sodium and chlorine. We know that in outermost shell, hydrogen have 1s1, so it will show both the properties of alkali metals and halogen. The correct answer is hydrogen. Okay, as we proceed from left to right in group, what happens to non-metallic nature? Non-metallic nature, ability to gain the electrons is considered as a non-metallic nature. Okay, so as we proceed from left to right groups, what happens to non-metallic nature? It will decrease. Okay. What happens to the atomic size of the lanthanides as the atomic number increases? This is known as the lanthanoid contraction. Lanthanoid contraction. So what will happen? The radius will decrease. Okay. Bayer's reagent is which of the following? Bayer's reagent is acidified KMnO4, and KMnO4 also acts as an oxidizing agent also. Okay. Which of the following reason is responsible for the formation of alloy by transition elements? For the reason is they have nearly same atomic size. That's why they form the alloys. The pair in which both the elements gradually shows only one oxidation state. Options are scandium zinc, zinc and copper, copper and silver, and zinc and gold. The correct option is scandium and zinc show only one oxidation state. Clear? Next question. Which of the following characteristics of transition metal is associated with higher catalytic activity? Transition elements show higher catalytic activity because of variable oxidation state. Okay, it shows D block elements show variable oxidation state. Next, transition elements show variable oxidation state due to loss of electrons from which of the following orbitals? They show a variable oxidation state because they have the energy gap, large energy gap between n-1d orbitals and n orbital. That's why the oxidation states are variable, different. Clear? So the next question we are moving towards color of transition metal ions are due to absorption of same wavelength. This is result in the DS transition, SS transition, ST transition or DD transition. This is the DD transition, by which D block elements form colored and they absorb light and move to the higher excited state. Which of the following factor may be regarded as the main cause of lanthanide contraction? Main cause of lanthanide contraction is the poor shielding of 4f electrons. Okay, 4f electrons and another in the subshell. So because of the poor shielding effect of 4f electrons, the lanthanide contraction happens. Last question. Cesium Z is equal to 58 is an important member of the lanthanoids. Which of the following statement is cerium is incorrect? So the common oxidation state of cerium are +3 and +4. The +3 oxidation state of cerium is more stable than +4 oxidation state. The +4 oxidation state of cerium is not known in solution. This is incorrect answer because it is present in the solution. +4 oxidation state cerium shows. Clear? So these are the all MCQs of D and F block element. All important MCQs are there, you can see. So I hope you like my videos. Keep preparing for the board exams and have a good preparation. Best of luck. Thank you.